Hey everybody, thanks for coming to this workshop. I'm just curious, how many of you have had experience using a solderless breadboard before? Oh good, quite a few of you. I'll just briefly explain how they work in an upcoming slide, but let's start a little bit and talk about what we're going to do. Excuse me. We're going to make a circuit using a solderless breadboard and attach paper clips to a piece of paper that has this conductive ink, bare conductive ink. And what it allows you to do is basically draw part of your circuit on this paper with this material, and the electricity can conduct through it. And the circuit we're building allows your body to actually be part of the circuit, so that when you put your fingers across those little gaps there, you can complete the circuit, and you can control the LED, the way it blinks and stuff like that. So what I want you to do pretty soon, let me just talk a little bit about, well, maybe we should start with this because it takes a little while for the conductive ink to dry. So why don't you go ahead and start making a pattern on your paper that's similar to what you see here. And I don't know if you need to, if that solution, I don't think you need to stir it up, do you, Nick? It's good to go? Okay. So as you see, there are paper clips attached to the top of the piece of paper there. So you want to make sure that your terminals end pretty close to the edge of the paper, so that when you attach paper clips, the paper clips will actually reach over there. And so you can follow this basic design. If you want to extend it a little farther down the paper or make a kind of a curvy design, be artistic, show your style, show your personal style when you do this. And while you are doing that, I'll talk a little bit about the components in the project. The 555 timer switch is a really commonly used component in electronics projects, and so it's quite versatile. You can do a lot of things with it, but basically you can use it to control pulses of electricity, and they can be timed depending on what you hook up to the terminals, the kinds of capacitors and resistors you attach to it. You can control the timing of the pulses. And so we have a preset circuit for you that you're going to use, but you're welcome to experiment with it and try doing different resistor values and things like that if we have some. While you're painting, I'll explain a little bit about how a breadboard works. I wish that we could peel off the top of the breadboard so you could see what it's like, but what's going on is these holes are where you poke wires and the leads of the different components into them. And you can see what we have here. We have rails, and the rails on the ends there, on either end, those holes are all connected by metal strips that are running vertically down the length of the board. And those are typically where you can connect your power, your plus and minus, to supply power to the breadboard. And then horizontally, you'll see the blue dots and the kind of orangish dots. Those are what we call terminal rails, and those are connected horizontally like that. So each row is all part of the same wire underneath, or metal strip underneath. And so when you're putting together your breadboard, you keep that kind of thing in mind, so that you make sure that you have connections and don't have shorts.
Sorry, the next slide will show what you're talking about.
Oh, okay. And here it is with the top removed, actually, so you can see how it actually works. And you can see below those metal fingers there. That's what's pinching the piece of wire or lead together, so that ensures good contact. So you see that piece down there with the 5 fingers, that represents a row of the 5 holes that are above it. Okay, so here are the materials that you're going to be using. You've already started using your conductive ink. We've got some wire, we've got the breadboard, the paper clips, an LED, which is a light emitting diode, and there is a polarity that's involved, so we'll go over that. But you'll see that one leg is shorter than the other. And so it's important when you insert that into the breadboard that you do it the right way. It's not like a light bulb. It has to go in one direction or it won't work. We have the timer chip. We have a couple of resistors. If you're not familiar with a resistor, an analogy is think of a resistor like a kink in a garden hose. And the higher the resistor value, the more of a kink there is. And then we have a capacitor. And I don't want to give you the definition of a capacitor because I will screw it up and won't say it, but I'll say that it holds a charge and releases an electrical charge. It builds up electrons along a large surface area and then releases it very quickly, kind of like a battery. There, I probably given you the wrong definition in 3 different ways. So anyway, this is the basic wiring schematic that we're going to be using. And you can see the timer has different pins on it. It has 8 pins. And this shows you the components that you are going to attach to the different pins. But really what we'll be working from is a nice breadboard sketch, so you don't have to figure out how to do a wiring schematic. So just a little bit about conductive ink. You can actually make your own kind of conductive ink if you want, or you can buy pre-made ink like the kind that we have here from Bear Conductive. And here's the different kinds of things you can do with it. You can make basic circuits like switches or sensors. It's fun to make greeting cards with them, or interactive art where you invite people to touch them. You could even have friends holding hands together and then touching the ends of the Bear Conductive material. Print your own circuit boards, and the ink works on a variety of materials, not just paper. So you could paint it on anything you want. You could paint it on a wall or on a piece of glass or a desktop. So luckily you've already started painting these so that it can start to get a little bit dry when you're done. It takes about 10 minutes for it to dry completely. We might go ahead and start working on it when it's a little bit wet, but watch out about getting this stuff. Oh, I should warn you, it's like tar. Don't let it get onto your hands or clothes. It's kind of messy. Here's some different sensors that people have painted, and pretty cool options. If you haven't finished yours yet, you can have this be inspiration for you. The trick is that each lead extending off the paper clip does not touch anything else. Topologically, it's just a line segment. Okay, so I will wait for everybody to kind of finish up. I'll hold this slide for a little while, but what we're going to do is kind of construct the power subcircuit for the circuit board. So you can see you have a 9-volt battery and a clip. And so if you attach that clip to the battery, and then notice that the power rails, the ones on the side of the board, one is next to a red stripe, and one of the columns is next to a blue stripe. So you want to put the red wire from your 9-volt battery clip into the rail that is closest to the red line. And then the black one goes next to the blue stripe. And that's just a convention. If you wanted to do it the other way around, just because you were being rebellious, you would have to be consistent throughout the project. But anyway, it's really simpler to do it this way. And then what you're seeing is that you're jumping a little down on the right-hand side of the board. You're jumping the rail, so you're connecting a black wire from one blue rail down to the other blue rail, and then a red jumper wire from the red rail to the other red rail on the other side. And then that way you can draw power from either side of the breadboard. And is anybody still doing this part, or raise your hand if you want me to stay on this slide. Okay, I'll stay on it for a little bit. And Nick, if you see anybody that looks like does anybody need help? Because Nick is really the one who designed this circuit, so he will be able to help you in a flash. Raise your hand if you need help. I think some folks over there. Okay, I'm going to go ahead, while Nick's helping those folks out, I'm going to move to the next slide here. Okay, so now what you want to do is put the chip in, the 555 timer chip, onto the board. And the way to do it is you want it to go in between. There's like a little valley on that board, and that separates the two sections of terminal holes. So notice that there is a little semicircle on the end. We're calling it a dimple here. There's a semicircle on the end of the chip. You want that facing to the right. And so if you can put that, if you just want to follow this exactly, you can put that chip right there so that it's the pin number 1 is 4 holes down, 4 holes to the left. And so the pins on a chip, and this is the way all chips work. You start with that dimple. Most chips have a little, either a white dot or a dimple. You count in a counterclockwise fashion, and that will give you the numbers of those terminals. So we have 1, 2, 3, 4, 5, 6, 7, 8. And you might have to kind of like pinch the 555 timer chip a little bit to get it so that it fits in there, because the holes might feel like they're a little too close together between the two rails. So if you kind of slightly pinch on the 555 legs, they'll fit in there easily. Is anybody having, and make sure it's seated firmly. Is anybody having trouble getting them in? Okay, good. So we're going to move on to the next step. Okay, now we're going to supply power to a couple of the pins and then connect one of the pins to ground. So you can see here it's pretty straightforward. Use one of the jumpers from pin 1 to a blue rail, and then pin 4 from pin 4 you want to connect to the 9-volt power, and then pin 8 you're going to connect to 9-volt power. And so you can see why we did that jump, because it's handy to have power on both sides of your board. You could, if you wanted to, connect pin 8 with a longer jumper wire over to that other side, but you would see that it would start to look a little bit messy. This way you can have a little bit of a cleaner circuit. The other thing is we have one here. If anybody's having trouble knowing where things are, you can run up here and take a look at the way we've got it set up. So this should take you a few minutes to do.
Kind of small, but there's more details about the specific components.
Oh, okay, cool, thank you. I'm going to go ahead and jump to the next slide just in case you are ready to go. You can still see where to put the wires for that previous step, but what we're going to do is put a 2.7 mega ohm resistor on pin 2. And so you can tell that resistors have color coding. And so this one you can see is red, purple, green, and gold. And if you don't know about resistors, each color is represented by a number. Like red is a 2, and purple is a 7, and then green is the number of zeros, and then gold is how precise the resistor is. I think gold means that it could be 5% precision. It could vary that much. So all you have to do is attach one end of the resistor from pin 2 and the other one to the 9-volt power. And it doesn't matter about the polarity of the resistor. It could be either way. Resistors are, there's no plus side or minus side. It works perfectly well either way. That's not true with some components. Some capacitors have polarity, and all light emitting diodes have polarity, so you have to be careful about that. Okay, I am going to move to the next step. Does anybody want me to stay on this step? Okay, let's move to the next step. Okay, so this one we have a couple of things that we have to do. We're going to add an LED, and we're also going to add another resistor, which is called the current limiting resistor. So what you want is to get the 330 ohm resistor, which is orange, orange, brown, and gold. And there's only one like that, an orange, orange, brown, gold one. And you want to connect the resistor to pin 3 on the 555 timer, and the other end you can connect to a free section on the breadboard. So approximately where you see it right now is fine. And so after you get that into place, you're going to take the long leg of the LED. Remember I said there was a short leg and a long one? The long one's a positive leg. And you put that in the same terminal rail as the resistor. So you want to just make sure that wherever you put that other end of your 330 ohm resistor, you want it to be in that same column so that you have a connection between those. And then you're going to take the negative leg of the LED, and you're going to put that right into the ground rail. Now there's a reason that the reason we're putting this resistor there, it's called the current limiting resistor, is because if you were just to give that LED 9 volts of pure power coming out of the timer, the LED would burn out really quickly. So this way it will preserve it and protect the LED. So that's an important thing to do. How's everybody doing? Is anybody having problems? Right over here. Okay, Nick will help you out there. Okay. And do you have a question also? Okay. We'll have Nick. Nick will help you in a second. Okay, I'm going to move to the next slide. Is everybody ready? Okay, so for this one, we're going to install the other 2.7 mega ohm resistor that we have. You should only have one resistor left in your kit. Okay? If you have more than one, either we messed up or you messed up, but we'll make it work. So it's going to be just like you see, red, purple, green, and gold. And take one leg of that resistor and put it into pin 6 on the 555 timer. And then the other leg you will attach to the ground rail.
I don't know. I might as well.
So take a look at that one. And then once you're done with that, you'll see you have a little component that is a capacitor. It's a 0.01 microfarad capacitor. And fortunately, we are using a ceramic capacitor, so there's no polarity. It doesn't matter which way you put it in. Either leg in either of the terminal holes will work. So what you want to do is you want one leg of it to pin 6, and the other leg you want to put into ground. We're getting very close. We're getting very close. You have some wires left, and you'll see what we'll do with that. Okay, I'm going to move to the next step. Unless does anybody want me to hold on this? Stay on this one. Okay, great. You guys are going fast. So we don't have soldering irons, but what we can easily do is just attach wires to the paper clips. And take a look at the orientation of the paper clips here. So we've got see the way that they clip. You want to be able to have that end that doesn't have a wire attached to be able to slip onto the paper. So you want the loops, the I'm not saying it right, but you want the parts that have the semicircle curves in them to be not the side with the wire. And so just wrap it around as tightly as you can with your fingers. And you're going to want to do that to all four, one paper clip per wire. And I think you probably each have 2 yellow and 2 blues. And once you get those wrapped, then you can put them. You can put the 2 sets of wires into the circuit, as shown. But I'll wait a couple of minutes. And you also notice that you have wire strippers if you don't think that your wire is long enough to twist onto the paper clip. So once you get the paper clips on there, what you want to do is you want to add those 2 sets of wires to the circuit. So wire 1 yellow wire to ground, and then attach the second wire to pin number 2 in the 555 timer. And you can see you just have those the other ends are the ones with the paper clips attached to them. So then you do the same with the blue. You put 1 blue wire to pin 6 and the other blue wire to pin number 9. For some reason, your LED is already glowing. Is that okay? Okay. You've got a connection somehow. If Nick says it's okay, I believe him. And if you've so the next step, as you might guess, is to attach the paper clips to the sensors. And look at, you see that you have the yellow ones are adjacent and the blue ones are adjacent.
Can we go back to that last slide?
Yeah, sure. Yeah, you bet. So if you've already gotten all the wires in and you want to go ahead and attach them to the paper like I showed you on that other slide, this slide, go ahead and do that. And and start to touch them and see if you can get the light to light up. Let's see. Let's see. Let me just try something here.
I probably just did it wrong. I was kind of just doing my thing.
Yeah. That's, well, you know, it's rare for anything to work the first time out anyway. One thing to check is to make sure that these things are plugged in all the way, yeah, and that you don't have pieces of metal, bare metal wire touching each other, yeah. So give that a look. As long as you have two that are close to each other and two that are like two blue and two yellow. Right. Here's one thing to try. If it's not working, just take like the two yellow paper clips together and touch them together and see if you can get the LED to light up. And if it's not happening, then that means there's something wrong with the circuit. And if the two yellow wires, when you touch the two yellow paper clips together, the LED should light up, and then take the two blue ones and touch them together, and it should turn the light off. So basically, we've made a touch-sensitive light switch. And if it's not working, take a good look at this circuit and make sure that you have everything in the right holes, that the LED is in the right polarity, that all the terminals are pushed in as far as they can go into the holes. And also, one thing that's really important is that make sure that if you have any exposed wires, like wires from the resistor or the capacitor, that they're not touching another bare wire.
I think our problem is we don't have that bottom right next to the resistor.
The red one?
The small red on the
Oh yeah, let's see.
we don't
Did we not?
but we don't actually have that.
Oh, we don't. Oh, that's interesting.
That's all it is. We're not-
Are we missing that piece? We might be missing. Okay, we will.
That is one.
We've got plenty of wire, and so we're going to make some jumpers for you quickly. So yeah, that's. That's pin 8. So is everybody missing the ones that's from pin 8 to ground to plus 9 volts? Okay. Welcome to the world of electronics. This is the debugging phase.
You're supposed to touch the two yellow lines together.
Yeah, just try touching the two yellow wires together.
On and these two will turn.
Yeah.
Touch two on.
Did you get it? Is it working? Very good. My hands are really dry and I can't even, well, there I go, but. Cool. Did you have, can you do it with one finger from one hand and one from the other? Will it work? I mean, both on the yellow, like one, yeah, like, oh yeah, that's, so, oh sure. Do you want me to go this way? Let me see. I think you're, like from finger to finger, the resistance between your arms and across your body is like about 500,000 ohms or so. And so that's quite a bit of resistance. But of course, if you were to put wires in an electrical outlet and have the current go through, it would be really bad. So hopefully you guys have had some success with this so far. I've seen one working. Raise your hand if you've been able to complete the circuit successfully. Oh, good. Good. Now raise your hand if it's not working. Okay. And if it's not, don't be like discouraged or feel like you failed, because when you do electronics, circuit building and things like that, it's par for the course. You're going, is rare. I think it really is rare to put a circuit together, even a simple one, and have it work the first time. There's always something you're going to run into. And if you don't fry a component, that's great. Did it get hot?
Oh yes.
It smoked. Sorry about that. If you had a very small egg, you could fry it. That means you probably have a short in there somewhere with the way it was wired. It can get hot, and it may have cooked the component so that it's not going to work anymore. Yeah, don't burn yourself if possible, but I don't know anyone who's worked with circuits who hasn't burned their finger. What time is the next session?
We started a little bit late, so probably about like a few more minutes.
Okay.
Yeah.
I'm just looking at what I am doing my next thing at supposedly at 3:30.
Okay.
5 I got to be on stage for the final thing. 3:35. So maybe I should tell people to clear out. And the people they're not taking these home with them, right?
No, they can take the paint to but
Okay.
leave everything else.
Okay. Okay, so I want to thank you for coming and giving us the opportunity to show you how to do this. We're going to have another, we have another group of people who are going to come in and take the workshop now. So you are welcome to take the piece of paper with your beautiful artwork on it and take that home as a parting gift. But go ahead and just leave all the other stuff on the table. Just pull the paper clips off.
We'll post this on the make page if they want to look for it.
Okay. Also, if you want to make this at home and you're able to get the materials for it, we will have full instructions on makezine.com. And you could probably also buy the materials, everything you need on Make. So thanks a lot for coming. I really appreciate it. And I hope you enjoy the rest of this wonderful Engadget Expand weekend. There's tons of great stuff to see. And make sure to check out our Make booth where we have some 3D printers in operation and a demonstration. There's some really cool 3D printers and things that are happening. We have a 3D scanner. You can scan yourself and take home a miniature 3D voodoo doll of yourself. Thank you.